I get to introduce this guy. I know him pretty well. He's my father, and it's a real. I think it's a great honor for y'all to be able to hear a bit of what goes through his mind. He often will stand in a place and just, you think he's staring off into space, but he's not. He's always thinking and processing. And I can recall, I feel like sometimes it's a moon trait in which we often will sit in silence in the vehicle going to places because we're just thinking about different solutions or ideas or whatever. And so I would often, but when I was growing up, I thought that it was just that the rat hadn't quite got on the wheel. So like, I'd ask the question like, how's it going? And it was like, it's good. So I just learned to ask different questions, like, what are you thinking about? And my dad would say, did you see that down the street? You know, if they had this, and this, you put those things two together, then they could have done this. Or he'll, and he's such an encourager. So there's lots of things I could talk about him, but his background is, he got a degree in oceanography and a degree in mathematics and a degree in engineering, and did all sorts of things. And he chose to. There was an opportunity. He tells me this story that he was working for a large environmental firm here in Seattle, and there was a time in which he. The next promotion was available, and that promotion was going to take him traveling quite frequently. And so he had this choice between doing that or not. And he started having kids, and he said, I'd rather be available for my kids than to go after that job. So Moon Construction was created. And so with that, I welcome Cliff Moon.
I thought that I would share a couple of stories with you this morning. I have some pictures of some things that we've done, some recent, but the one on this particular one on Sumas is a little bit a bit older, but it'll give you some examples of how we as a construction company have been known for taking on projects that are difficult or no one else wants to do. And that's given us a niche in the marketplace for that kind of thing. And sometimes it gets us into trouble, but it's still fun. You know, what Jeff was saying this morning, the other night, I couldn't sleep. And so I thought, if I'm still awake at 11 o'clock, I'm going to get up. And so at 11 o'clock, I got up. And I'm thinking about some materials that we need for a job that Jeff and I are working on. And so I rolled out the drawings, and I'm looking at them, and I make a list of some hangers that we need. And it's just a list, except I took a picture of it and sent it to the supply house, to the salesman. And he looked at it, and he says, I got to come and see you. And I says, well, we're at the job site. So he shows up, and he has the picture of the list that I made. And the list is in order of where the different brackets go. And he thought that was so easy for me to follow. I know you need this bracket at that location, this one in the middle, and this one over here, so forth, that kind of thing. This is Sumas, Washington. It's it's east of Blaine. It's a border crossing. And this building that you see there was built in 1931. And it was the Customs and Immigration building for those years since it was completed in 1931. It's considered a historic building. And the chimneys that you see at each end are the home of a endangered species of swift, a type of bird that that migrates north and south, and when they stop over in Sumas, and they will go down inside that chimney and roost for a day or two. And I don't know much about birds except that I've understand that there's a hierarchy when the birds go down into the chimney in terms of the age of the bird. And it's interesting, isn't it? You wouldn't think that. But there is probably 40,000 birds that will go in those chimneys. So it's a very large number. So you'll see, and I've seen it. I've seen where there will be a cloud of birds that comes over that building, and then they'll just begin to circle, and then they'll just funnel down inside the chimney. It's just an awesome thing to do. And then they have contests up there to find out, what day they'll show up, or what hour they'll go down into the thing, and that type of stuff. So it's interesting. So now, here's the unique thing about it. 6 of these buildings were built in the 30s. There's only 2 remaining. One in Connecticut, on the border between Canada and Connecticut, and the one at Sumas. The other ones have all been demolished or destroyed. The federal government, GSA, decided that they needed to build a new Customs and Immigration crossing at Sumas. That's the railroad crossing into Canada, is at Sumas. I mean, for the commercial products, and also a big truck stop as well. So they put out a contract to tear this building down. And I had been away and came back, and these drawings had been mailed to me for this building. And these drawings are dated in 1930, 1931, 32. And the government wanted to bid for me to tear this building down. And I thought, we can do that. And so I gave them a price of just shy of $200,000 to take that building down. And then we were awarded the job. We were the only bidder. Nobody else bid on that. And then I went and looked at that building, and I thought, gee, that's really a neat building. And there's a building in downtown, in Edmonds, at the foot of 3rd that looks similar to this building. Actually, it's a wood frame building, but it doesn't have the brick on it. But anyway, I thought, gee, why would you tear that building down? So anyway, we began the government said, well, your bid's too high. We only have $125,000. And so I thought, gee, maybe we could do something. So I thought that we could move this building. And I thought, if we moved the building, we could make a bed and breakfast out of it. We could make an office building out of it. And so I negotiated with the feds that we would move this building. I had the original drawings. I still have some of them, and I had some original pictures too from back then. But they estimated that building weighed 70 tons. And since I had the original drawings, I did a takeoff, and I came up with 340 tons. Bit of a difference. Well, the feds, you can't believe everything they do. I gave it to an architect, and the architect looked at the drawings, and he came up with 347. Oh, that's pretty good. That's only 7 tons off. And we got a house mover or a mover, a building mover. Now it's really interesting in the building moving business. There are a number of movers who will move a structure that's less than 25 tons, mostly in the 5 to 7 ton arena. That's typically a weight of a house. Then there's the next hierarchy is 100 tons, and then you go from 100 tons to 300 tons, and then they'll go up to bigger projects. And you rarely see people that'll move a building that weighs so much. It's just really, really, really difficult to do. We found a mover that, there's a couple of movers, there's several movers in the greater Seattle area, or there used to be. I think there's maybe only one or two left. And I've drawn a blank on what the name of it is, and they're still around. And you see them sometimes in a paper because they're moving a building. It's a big deal. The mover that we selected said the building only weighed 300 tons, and I will charge you $70,000 to move it. And if I don't get to the end of the story, I'm into it $676,000, and it weighs 1,024 tons.
Oh my gosh.
That's greater than a 747. So here's the process. I was older then. Here's what we did. It's a 2-story building with a basement. And what I need to stay in one spot, right? What we did was that we picked the top of the doorway in the basement as the area to saw cut the concrete through the whole building. And the concrete is 16 inches thick. So right away we're starting off with an issue that doesn't quite work. The second issue, when it rained, what we did is we excavated around the exterior of the building so we could get a saw down there, and then we would cut horizontally along that. We took horseshoe nails and drove them into the spacing between where we were saw cutting about every 6 or 8 inches as he would move the saw on, so the weight of the building wouldn't pinch the saw blade. And so that enabled us to continue to do that. One of the things that we ran into is that when it rained, that became very sloppy and it was hard to work in, right? Now, one of the things that I learned in high school in chemistry class was a thing called water glass. You ever heard of water glass? Well, what the teacher did was that he took 2 types of solution that looked like water, and when he mixed them together, it became solid and milky white. And what is that? It's sodium silicate and acid. So I bought a drum of sodium silicate and some jugs of acid, and we mixed that in that soil and solidified that soil so that we could walk on that when we were saw cutting. No way you could do that today. You get environmentalists all over you, but you know, those were the tricks of the day. We had to, in addition to saw cutting all the way through, we had to cut inside as well as outside. We had to cut these openings so that we could slide some steel I-beams underneath that structure. And then we began to pick it up. Now the mover brought in some 18-ton jacks. He had 20 18-ton jacks. And that, each jack, that means that each jack would support or lift 18 tons. And so he put those in there underneath that cribbing, and the building wouldn't move. We ended up with over 50 jacks to pick this building up. That's when we decided. And here's the other unique thing about it. He has a control box. These are all hydraulically driven. All right? He has a control box, and each line goes to an individual jack. So as he's standing there watching this building, he can adjust each jack so that the building rises uniformly and not tilted in any way. It's a very clever way. So with 50 jacks, we were able to raise that building 6 inches a day. It took us forever. It took us forever. And then of course, when you sign a contract with the feds, they say, you've got to be finished you start on day 1, you got to be finished on day 2, and there's just, it doesn't work. It didn't in that case. So there it is, up in the air. And we did not break any windows or crack any brick or anything. The other issue in this scenario was we needed a place to move it, and I looked at property up there where we could if we could get 3 or 4 acres, we can make a bed and breakfast out of it. If we could get it closer to town, we could make an office building out of it. I'm thinking retirement, guys. I can rent this thing out and get up later in the morning. So I was just here getting this thing ready to move, and I don't have a place to move it. And another contractor in the Sumas area owned an apartment building. And I bought that apartment building, tore it down, and we created a spot for this building to get moved to. And which is only 600 feet away from this, but it was you still had to move it. The wheel structure that we had to put underneath that, 128 wheels to move it. Then the day we went to move it, the Sumas River flooded. And this is November. So we're kind of stuck, and the waters recede, and now the city is saying you can't move the building because you will destroy our roads. Because the roads because you saturated the roads and you put all this weight on it, and it'll break their road structure. This was a very popular project. We were in the local newspapers. We had people fly in from out of state to see how we were doing this building, particularly with the use of nails, to keep from pinching the saw blade. These wheels that we put underneath there were brand new, the first use ever. Each wheel is hydraulically driven, and so the idea was that you could steer these wheels would rotate, and you could move the building sideways, or you could move it around, and it was unique in that sense as well. So at 2 o'clock in the morning on a Saturday, we had a soils engineer out of Bellingham who wrote a letter, said the roads are fine, go ahead and move it, and so we moved it. We had to wait until the bars closed at 2 o'clock in the morning. because the traffic at the border was just, you know, we had so many people that were coming down from Canada or whatever back and forth. That's what we had to do. So at 2:30 in the morning, we began to move this building, and we pulled it initially into Canada. And then there was a big hoopla over that. You know, we had to have, there was a big press deal, and there was papers passed back and forth about, you know, bringing product into Canada and bringing it back. It was kind of it was a fun thing. It was, you know, it was more, you know, more fun than it was serious. We moved it to this site, and then had it, and then we built a Sumas. Geologically is a site of an old lake bed, and so we had an engineer, structural engineer, we still use to today, that designed a concrete slab, a concrete pad for us that had 2 levels of rebar in it, 16 inches thick, that we spread out that would float that building. So that no matter what soil conditions were around us, if the building would not only float on the surface, but it wouldn't rotate at all. And so that was one of the tricks. Then we had to rehab it. The problem was rehabbing it is the river flooded again. And so we couldn't do anything up there. And now we have the city that's saying, if you don't get this building buttoned up, we're going to have to destroy it. You know, so here you're caught between the feds wanting you to move it and get it off their property so they can build a new customs immigration building, and the city that wants this thing, you know, they don't want an eyesore because we're a tourist town and whatever. So anyway, the long and the short was that we were able to set it down. Now we had to set it above the floodplain. So it's probably close to 5 or 6 feet off the roadway, so that it'd be above a 100-year floodplain. One of the unique things that we did was that there's a product called gunite. It's a concrete product that's been around for a number of years. And you often will see when a contractor or where there's a project that has a deep hole where they're putting in parking or something below the street level, you will often see where they've sprayed concrete on the perimeter of that. And that's what we would refer to as gunite. It's sprayed on concrete. It's mostly a sand and cement mixture with maybe some very small chips of rock in it or something for a binder. And so it's a product that's out there that you can use for this. Now, there's a man named, his last name is Jolly, and I can't think of his first name, but we're probably similar in age. And I want to say his first name is Jim, but he took gunite and made rocks out of gunite at Woodland Park Zoo. And we were talking about how he had done that. And now you will see throughout the greater Seattle area where there's an embankment that looks like it's rock. That's gunite that's been drawn and caressed to make it look like rock, but it's actually gunite. And so we had this conversation. So what we did was that we had this thing sitting up high, and then we put rebar in front of we put rebar we drilled rebar up into the footing, or up into the building, and then down into our footing, and then rebar mesh, and then we put some metal studs up on the inside of the building and some sheetrock over the metal studs, sprayed it with gunite. That gunite is probably 7 or 8,000 psi, which is twice or 3 times what normal concrete would be. We did a project for the Port of Seattle in which they had to do some earthquake proofing, and they needed to build some concrete walls inside of a building, and I thought, we can do that. And so we did the same thing. Only we went in there, we created this wall of rebar and plywood behind it, brought in a spray rig and sprayed gunite on it. That was a fun project. One of the things that we had to do for this building was to create a ramp, an ADA compliant, a wheelchair ramp, so you could get up into the building. And there's a number of ways to do that, but for us, we bought bales of hay and stacked bales of hay along the side of the building, created a slope, put rebar on the top and on the side, sprayed it with gunite, and we created ourselves a handicap ramp into the building. It's an alternate use of hay. And we've done it more than once now. We did a year ago. We did an outdoor deck for not quite a deck, but an eating area for a facility down in Burien. And the thing was going to be about 2 feet off the ground, and we didn't want to pour 2 feet of concrete. So I went to Home Depot and bought 2 pallets of bark in bags, and we just laid the bark inside this perimeter, or inside the perimeter of this eating deck, filled it with gravel on the inside, poured concrete over it, and we had 5 or 6 yards of concrete and 200 bags of bark. So anyway, it's done. That's what it looks like. I had great envisions we rehabbed it on the inside, and during the rehab part, we had to upgrade the electrical, and so we drilled. In order to bring power into the building, we drilled a hole through the wall so we'd have a new electrical panel. And that core, the core driller gave that to me, and I thought, boy, this is heavy. This is really odd. So I went to the University of Washington Engineering Library, and it turns out that in the 1930s, in many areas, brick was not fired. It was compressed, hydraulic compressed. You go to Home Depot, and you buy a single brick at Home Depot, it probably weighs less than a pound, at most a little bit more than a pound. In 1930, bricks, an individual brick, same size, 2 inches, 8 inches, 4 inches, 8 to 9 pounds per brick. So we have, in my mind, a changed condition with the feds. You said it was 70 tons. We now have proof that this thing weighs significantly more. I want more money because I'm into this so heavily. And I've leveraged everything I own. We've refinanced our house, we've done this, we've done that. Borrowed from Peter to pay Paul, and $676,000 is what we're into it. So it goes to court, it goes to federal court, and we win. But the argument I'm trying to negotiate something before it goes to federal court, and the Fed said, well, once you moved it off the site, it's yours. We have no responsibility. If you'd left it on the site and told us it weighed more, then maybe we would talk to you. So that's why it went to court. And we won because of a clause. You have a changed condition. It's different than what they had proposed. It's in writing that they said it weighed 70 tons, and now we know it weighs 1,024 tons. And mostly we know that because of what it took to lift it up, but now we have a material proof of why it weighed that much. So we won, but we lost. How did we lose? When you go to federal court, they only allow $40 an hour for attorneys. That's their rate structure for an attorney. Where can you get an attorney for 40? You got to add 300 to the front end of that, in order to make it work. So even though we won, we still lost because it was significant. There was some attorney fees associated with it. We got a little bit more. I think we got, if our original contract was 125, we may have gotten $350 out of it. We're still in the hole, So I'm still thinking that we can make this into some useful building, and we'll have tenants, and I can borrow money, and we can have a mortgage, and you can play that game. So I borrowed some private money, and a man who was an airplane pilot for Pan Am, and he had a trust account, and in that trust account he had money, and he lent money to me at 12%, so I could rehab it. So that's okay. I get it rehabbed. Now I can go out and get a mortgage and up and running. It's just the entrepreneurial spirit here. Well, it didn't quite happen that way. One, I reached a point where I couldn't pay the interest on his loan, and it went from 12 to 25%. And he said, "I want that building." Oh gosh. And so he did. He got it. He got the building. He, in turn, lost it in a divorce to his wife, who in turn lost it in foreclosure on her side. I don't know who owns it now, but it is an office building in Sumas, and that's the kind of the end of the story. That's our grandkids we had a neat little deal. You could when we got it finished and we had lots of tourists and stuff. People would come and they would write notes and that kind of thing. So that's the ups and downs of it, but it was a fun project. So yeah. Anyway, so this is how we advertised it: windows to the past and future, office space at the historic CMS Customs House. So there's still only 2 buildings left: this one in Sumas and the one in Connecticut, up by the headwaters of the Connecticut River. There's a crossing into Montreal or whatever. I got 1 minute.
Oh, he's telling you you're number 1.
Oh, yeah. I doubt, yeah. Let me show you a neat trick. Will it go to that? This is just another. We have to build. This is this last summer project where we were building foundations and stuff for portables for Lake Washington School District. We had. They want a canopy, a playground canopy, and so we have to. Let's see how we can do this too fast. There we go. This is a canopy that they want, and so we have to. You see those bolts sticking up out of there? That's threaded rod. We had to. That threaded rod is 2 feet long, and it had to be embedded so that if there's any wind lift if you get wind underneath the canopy, it'll lift up the building. So you got wind lift. So I have to put these bolts at a very exact location, and the reason I have to do that is so that we can set that steel column on it. And that steel column isn't round; it's square. I mean, you can see the sides on it, and you have to be able to set that that down right at the right location in order for it to fit. And I'm thinking in my mind, how can I, what kind of a template can I put on there in order to make that work? Well, if I make a paper template, it'll get wet when you pour concrete. If I make a plywood template, I can't get concrete around it. How do I do that? Well, here's a trick. The trick is this apparatus right here. This is called a strong arm. This is a plumbing part. In a plumbing industry, you will have studs on either side of this, and through these holes becomes hot and cold water. This is called a strong arm. And they come in different sizes. Not related to this thing at all, right? But if I take and I cut this in half, and I screw this to the side of that cardboard column, not only can I have, in addition to that, these things slide back and forth. I can put that right exactly where it needs to go. And so we did. And that's using a material not intended for that particular purpose, but works for what we want to accomplish. There's the finished product. I find it hard to give up. You know, I just keep persevering. And yeah. Persevere.
Great story. You persevere and you find a way.
Yeah.
You do both.
Do both, yeah.
Yeah.
Yeah. There's certainly, this is not the first time. I'm the risk taker, you know, to do that kind of stuff. You have people who say, you should just declare bankruptcy, walk away, let it go. And to me, that's not an option. We got, in the early 70s, we got stuck with a project that funds were embezzled by the lender or somebody in the lender's office. The owner couldn't pay us. We were just really struggling. And I went to every supplier, subcontractor, and said, if you work with me, I'll pay you back with interest. Took 5 years, $500,000, and we did it. Don't give up. Bankruptcy is not an option. Well, you may be forced into it, but to me, not an option. There's got to be a way. Always a way. Always a way. Yeah.